Hello Team Mobius and welcome to my channel. On today's video, I'm going to go ahead and go over the circuit boards that are going to go ahead and go into the motor. And I'm going to explain and show you how they work. So let's go ahead and get started. Okay, as far as the board, we have an output minus, an output plus. We also have a V in and a V out, which is what we're going to connect the power input to. And then the output, of course, is the out minus and then the out positive, depending on which polarity you want the magnets to be. And then on the left side, from the top, we have a high PWM. In the center, we have a ground pin, and then we have a low switch. When we're connecting this board, we are not going to use the PWM. It's just going to cause complication, and then we'll go over that over the Zoom call. So for right now, we're just going to use the low switch side. And then we're going to go ahead and use a Hall effect sensor. So our Hall effect has its magnetic detector at the top. It's a transistor looking thing at the very top. And then we have two green LEDs that are connected to an op-amp circuit. Now as soon as this detects a north pole, it will go ahead and trigger the output. So let me go ahead and show you the connection and how we're going to make this connections together from the circuit here to the power distribution board. So what I've done on the Hall effect board, I've connected it to a 3.3 volts to 3.7 volts power bank here. So I soldered it to this board. It's fully charged. I think it's like 4.2 volts. Don't exceed that. Do not hit 5 volts. These boards say that they can hit 5 volts. I fried it. So you want to use 3.7 or minimum 3.1 volts. I've seen that work with this. So on the power pins here, you have VCC to the far left. You have your ground pin. You have your D0, which is your digital out. And then you have your A0, which is your analog out on the board. Connected a USB cable here. I ripped it apart. Use something more professional than that, of course. So your first pin here, like I said, is VCC. So that's your positive pin. Your next pin is your ground pin. And as you can see, the green LED turns on. Now, once you bring a magnet over to the sensor, it will trigger on the Hall effect. See, so as the motor is spinning, it'll detect, you know, your RPMs if we set this right up on a microcontroller. See how the flashing pulses based on me moving the screwdriver up and down. And of course these are just magnets, you know, your standard magnets, neodymiums. And again, you know, you got to make sure you got the right pole. See, right here I'm really close, but it's the wrong side of the pole, so it's not detecting it. It's only the north side of the pole that it detects, which is good because we want it to only detect one field. We don't want it to detect both fields because we only want the motor to trigger on when it hits a certain field. Okay, so from there, I'm going to go ahead and disconnect this for right now. You're going to want to connect the ground pin, which is here. This comes out from your power supply, so you have your negative ground here that comes here, and I've split it off. So one end goes to your sensor, the other one goes to the ground here. So think of it as a common ground when you're connecting this. So power distribution board needs a ground from the sensor, and the sensor itself needs a ground. And then on the other one, you're either going to connect this to A0, so the analog out, or D0, digital out. Doesn't matter, both pins will work to trigger this on. So let me go ahead and do that. Let me go ahead and connect this. So I'm going to connect this to A0. And I'm going to connect the ground. Make sure, no, I'm going to connect ground, which is the white wire here. And then I'm going to connect the positive power supply. Now right now you see both of them on, and the reason for that is that ground is connected and it's creating a loop, so it's causing this to turn on. But there is a difference in amplitude, as you can see when you bring the sensor. There's a difference of brightness on this. I don't know if it's really picking it up on the camera. Doesn't really matter. When you turn on your power supply, it'll go to the state that it's supposed to go on to. So you can use that as kind of a debugging. Right now I have 15 volts going through this board. So I want you to watch here. There's a red LED here that will turn on once a Hall effect turns on. So as soon as I bring the magnet over, again facing the right polarity here. Okay, so let's flip this sideways. There you go. See, you can see the red amber light here turn on. Alright, let's go ahead and connect the digital multimeter so that way I can show you the voltage output as I trigger this on. But as you can see, red light and green light. So as soon as the green light turns on, it turns on this power distribution board. Okay, now that I have the multimeter here, as you can see, it's in the millivolts. You know, that's the normal floating of the multimeters here. They have like a little floating point as far as measurement, especially when you stick it on a circuit. It's a lot lower when it's not connected to a circuit, but there's no power going through this pins right here. Okay, so we have 0 volts, and now let's go ahead and bring the magnet over, trigger it on. Oops, and there you go. See, you have your 15.46. It's off. Bring the magnets close. 15.46, so on and so forth. So as you can see here, the slowness of the voltage reading is coming from the multimeter here and not the circuit itself. The circuit itself is pretty instantaneous. If not, you can adjust this to the delay here if you have one. But again, we'll go over that in the Zoom call once we have this connected. But as you can see, this is how the circuit works. So we're going to run it like this for now. I'm sending you the boards today, and then we'll go from there. Alright guys, as usual, thanks you for watching my channel. If you like this video, go ahead and hit the like and subscribe button, and I hope you guys have a wonderful day.